All right, welcome back. This is our review for summative number 2, and this particular recording is for spring of 2019. So, I know some of the names are looking a little similar, so we have to kind of differentiate. There's my pen. There we go. So this is from January 2019, so that way I know what I'm looking at later. Okay, so this section here, this is a retest. We already tested 6.6 polynomial operations, and we're going to see it again. And boy, oh boy, is that hard to see. I think it says 3x minus 1 to the third power. So this is a little more complicated than what we saw in the last test. I just had you raise it to the second power in the last test. But this is to the third power. So the way we approach this question is we write the binomial 3 times as a multiplication question. And then you have to do this in 2 separate distribution stages. So we always suggest that you guys distribute these back polynomials first. So leave this initial one in front. We'll worry about that one on the next step. And then 3x times 3x is 9x squared. And then you have a minus 3x with another minus 3x, so that's minus 6x, and then plus 1. So you can do that in, more stages if you need to have a little help with that distribution. But here, we're not done, because now we have to take the 3x and distribute it to everybody inside the green polynomial. So let's see here, that's 27x to the third minus 18x squared, go slow here, and then plus 3x. And then we're still not done because now you have a negative 1 that you need to distribute into everybody. There we go. So we have negative 9x squared, which I'm going to write right here. And then plus 6x, the negative, and then minus 1. So, final answer would be what happens when you add up all these like terms. So let me get my pen marking out of the way. There we go. We have 27x to the third minus 27x squared plus 9x and then a minus 1. So that's kind of like a hybrid of the 2 problems that were on the last test. The first one where we squared everything, and then the next one where we did binomial times trinomial. So rather than asking 2 separate questions on those skills, I just asked one nasty question. Sorry. Now this one, I was very concerned about what we saw last time, and remember we did remediate this topic because we were so concerned about it. So let's kind of read through the given information. We're selling coffee mugs, and then it says the revenue, which is R of X, is given by this formula. And then it says the cost function is given by this formula. So when they ask you for the price of one mug, like how much are you selling it for, that comes straight from the revenue function. So that's going to be $17 because you're taking $17 from the customer. And then remember the the profit function is found by taking the revenue and then subtracting the cost. Now I might suggest that you guys put even the word or the abbreviation for cost in parentheses because I think maybe that'll help some of you. So when you go to set up revenue minus cost, you're going to set up 17x, that's the revenue function, minus, and then that's where those parentheses come into play, 9.25x plus 400. But because we have those parentheses, that means we're going to distribute the negative to both of them. So 17x minus 9.25x minus 400, which of course I'm out of room. So I'm going to write it, I don't know, I'm going to write it up here maybe. So the profit function is, which I should call P of X, that was my bad. Oh boy, why can't I subtract? 7.75 minus X, minus 400. So there's the profit function. Now you're going to plug in X equals 2,000 to find the profit on 2,000 coffee mugs, which when I did that I got $15,100. So make sure you can execute all 3 parts of that question, identifying the cost of the object, finding the profit function, and then utilizing the profit function. So remember, I'm doing like every other problem basically. You can go and look at the key, make sure that you're doing the other ones correctly, and I do suggest you guys go through all of them as well. Practice makes perfect here. So again, this is a section, this is power functions. We already saw it in the last test, but we need to see it again. So here, what they want you to do, they give you 2 functions. I'm going to call this the blue function. I'm going to call this one the green function. And then it tells you on this first one to not only add them together, but they also want you to plug in a -2. So that's up to you how you do this. So for like a lot of people, they just like to plug in -2 into the blue function first, which you totally can do. So let's see what happens when I plug in a -2. Some of you tried to do this like in the old noggin, and it kind of backfired because you multiplied before you did exponents, and that's not really how exponents and properties of exponents work. So let's see here. That's a 28 minus 5. That's a 23. And then the next thing they want you to do is function g, plug in a -2. So when you do that, let's see what you get. -14 minus 21, -35. I hope. I don't know, I feel like I did something really stupid there. Time out a minute. I don't know, if I did something stupid, I'm at a loss. Okay, so now what we need to do is we need to remember that we're adding these together. So 23 plus a -35, according to me, is -12. Now, that's not the answer I had on my original key, so unfortunately I didn't show any work, so who knows what the heck I did. Alright, this next one. They want you to subtract the functions, but they don't want you plugging in any numbers for x. So this is going to be like a formula or a function question. So you're not going to get like a number answer here. So f of x minus g of x. Man, I really spaced this out stupid. Sorry. Okay. F of x would be 7x squared minus 5. And then you're going to subtract function g, which remember means you got to use parentheses. So that's what, 7x minus 21. So if we go ahead and distribute that negative, you end up with 7x squared minus 5 minus 7x, and then a plus 21. That's a 1 right there. Oh my gosh. It's not my morning, man. Alright, plus 21. There we go. And then when you combine like terms, 7x squared minus 7x. Oh boy, plus 16, I think. I'll go with it. It matches my key. So, okay, so this next section, they want you to multiply them together. However, they also want you to plug in a 2. So this is a case where there's a couple ways you can do the question, but for most of you, you just like to plug in a 2. Oh, that would have been nice if it was the same one as the first question, but it's not. So plugging in a 2 and then multiplying the answers together. So plugging in a 2 for function f gives me, that one does give me the same answer as -2 because of the squaring, but that's 23. And then plugging in a 2 for function g, that should give you a different answer than the first question. That's, 14 minus 21, so that's what, -7? And then you're supposed to remember multiply them together. So 23 times -7. Now some of you did some really cool stuff on your last test. I think it's -161. But you kind of did it all in one step. And if you do like all of this times all of this on your calculator in one step, you would have to remember to put parentheses around the functions themselves. So that way the calculator understands exactly what's getting multiplied together. So just a little word of caution if that's the method you want to use. Totally fine. Alright, this next one is supposed to be easy, so don't overcomplicate it. They want function f in the numerator, and then they want function g in the denominator. And then they want domain. So remember, domain is that the denominator cannot be 0. That's the thing that you can't have. So what you're going to do is you're going to set your denominator and then tell me that it can't be 0, and then you're going to solve it. So here's what I do. I go, alright, so 7x minus 21 cannot be 0. So then I solve it. So I'm going to add the 21 over, and then divide by 7, and we get x cannot be 3. This right here is your domain restriction, technically. So you say x cannot be 3. And maybe you could look at that formula and figure that out without actually doing a lot of work. That's awesome, but remember, sometimes they don't come out to integers. Sometimes they're fractions, so you want to make sure you have a process for how to find domain. And of course, I hardly left myself any room for this last one. It says f of g of 2. So you're supposed to, on this composition question, you're supposed to start right here. So finding g of 2, hey, we found that a minute ago, didn't we? That was -7. So this right here is -7. So now what they want you to do is find f of -7. We did not find that yet. Okay, oh my gosh. Could I have made this any squishier? Alright, so function f, which is 7 times -7 squared minus 5. Okay, let's see here. According to my key, that comes out to 338, but apparently I've been making some mistakes today, so if that's not correct, I apologize. Let me know. Alright, so there's another set of examples for you to kind of muscle through. Please do practice this some more. This is the entirety of the section. It's just those 1, 2, 3, 4, 5 problems. So you really want to make sure you know how to do each one of them so you don't suffer a concept mistake. Alright, this next question. Some vocabulary at the top, and then we're going to be using our calculator. So what some of us realized from the last remediation page we had, that if you actually start by typing this into your calculator, you're going to be able to answer almost all of these questions, except for the first three. The first three are just straight up vocab. So the lead coefficient is the number that's in front of your lead term, so that would be a -3. The degree is the highest exponent, so that would be a 2, and a degree of 2 is called a quadratic. So remember, I'm not going to quiz you on the obscure ones, but please do know quadratic, cubic, and quartic. It's going to be one of those. So now they want you to plug in x equals -5. How you do that is up to you. You can store it, but because our next step is to go to the calculator, you might want to go there. So go ahead and get this function typed into y1, and I will do the same, which I don't think I have it there yet. Oh. Any day now, calculator. There we go. I'm sure I have something crazy typed in. Let's go. Ooh, yeah, get rid of that. Alright, so -3 x squared plus 14x plus 9. And then I'm going to start with zoom 6. That's the standard window. Okay, not a great window. This was, remember, a quadratic function. The parabola at the top is a lot higher. So I'm going to go to window, and I need the top of the range to go higher up. So y max got to go bigger than 10. Let's go like 35. Hope for the best. Ah, good enough. Okay, so we can do a lot of things now. That next question that we haven't answered yet, where it wanted me to plug in x equals -5, you could just go to your table and get x equals -5, or you could hit trace and then type -5. That's another way for your calculator to plug in -5 for you. So that's kind of nice. You don't have to worry about, oh, did I type it right? Did I use parentheses right? I mean, if you have extra time on your test, you might want to verify some of your answers through the calculator. That's always a good idea, but not if you're running short on time. All right, so we have this, lovely quadratic that looks like this, and I think it would be really important for us to go ahead and identify this xy ordered pair. So let's figure that out. That is a maximum. So going to our calc menu and choosing maximum. Now remember, I have a very slow lag. I can estimate that the maximum is about between 2 and 3 right here. So something before the maximum would be like x equals 2. I'm just going to type a 2. Or not. Hold on. Let me get rid of that. Okay, now I'm going to type it. No, I'm not. Okay, I don't know what I'm going to do. Let's try it this way. 2. Okay, that was a little dangerous. It is before the maximum, but that was a little too close for my liking. I should have gone to 1. Alright, so now I need to get to the right of the maximum. I'm going to go to 3. I have the answer already, so I know what the maximum is. Okay, and then hit enter when it says, it says 2.3, 25.3. So back to my paper. 2.3 and then 25.3. Alright, so domain is supposed to be the easy question. It goes forever on a polynomial. So -infinity to infinity. But remember, range is low to high, and it's y values. So you're going to use this as the top of the range. your range starts at negative infinity with a parenthesis, but it stops at 25.3. Go ahead to round to the tenths place on those questions. If you want to go further and round to the hundredths, that's fine, unless it states otherwise, but don't round off to the whole number, please. And please watch your notation. I've been kind of gracious about how I'm counting you down, but from now on, if your notation is in the wrong order, or you're not using brackets and parentheses appropriately, that's going to be considered a concept mistake. Alright, so here for end behavior, you get the stamp again. X goes to negative infinity is a fancy way of saying the left end behavior. So when I look at the left side, I notice it's going down. So negative infinity. And then on the right side of your function, which is over here, it's also going down. Alright, so another example for you to try there. That's a good one for you to look at on your calculator. If you don't have a calculator, remember you can use an emulator, or of course just come in and use my calculators in the classroom. Alright, this is our new stuff, right? So factoring flowchart, you're going to want to have next to you that golden, the new one we have. And there's kind of two of every kind here. So, first step in every flowchart question is to look for a common factor. There's no common factor here. So we're going to move down the flowchart and realize that we have a special pattern. We have the sum, because it's a plus, so sum of cubes. So I want you to get in the habit of writing the pattern down, which is a plus b times a squared, minus ab plus b squared. So now the only trick you have to figure out is who is a and who is b. So on the cubic pattern, you need to cube root each of these numbers, which you can do on your calculator for the 216, or you can look at your box of cubic numbers and look at the list. So a is just x, and b is going to be cube root of 216, which is 6. So plugging in those numbers, we get x plus 6, and then x squared, minus x times 6, so 6x, plus 6 squared, which I'm going to write as a 36. I love that pattern because I know once I use it, I'm done. So once you muscle through who a and b are and plug them in the right spot, you're good to go. So you can go ahead and look at 5b on your own, and then next we'll look at 6a. So on 6a, back to the top of the flowchart, we have to look for a common factor. This time you do have a common factor of a 6 and an x. So, if we take a 6x out of that problem, you still are going to have an x squared and then a minus 9. Now what I just wrote down in green, that's another one of our special factoring patterns, but this time it's the difference of squares, which is the one that we're really comfortable with. That's the good twin, evil twin pattern. So 6x, please keep it out in front, and then x squared minus 9, we're going to factor into, take the square root of each, x plus 3 times x minus 3. So that pattern is still around. We're going to be using it a lot. And next we'll look at 7a. Alright, 7a is, so there's no common factor for all of the terms, but we do have 4 terms, which means we're going to group. So this is the kind of factoring where you look at the first 2 as a group, and then you're going to look at the, I didn't mean to do that. You're going to look at the last 2 as a group. Let's try that again. I need a fine point marker. It's not going to happen. Yeah, whatever. Alright, so factoring out the common term for the first group, I could take out a 3 and an x squared. So then you look at, okay, well what's left over when you divide by 3x squared here and here? See, I need smaller pen. And you're left with an x and then a plus 4. So then my next group, I can take out a 5, but I assume I meant a positive 5 by that, so I'm going to literally write down a positive 5. And then if you divide everything by that 5 in the second group, oh, what do you know? You're left with x plus 4. So these parentheses have to match in order to know that you're factoring by grouping properly. And then you take that x plus 4 factor out in front of the question. So basically we're taking the common term of x plus 4 and factoring it out of the entire group. And here's what we have left. You still have left 3x squared plus 5. So these are the ones where there's a big warning on the flowchart that says be careful that you don't have more factoring at the end. The only time you'll have more factoring at the end is where this difference of squares pattern might pop up again. And this problem didn't have that happen, so it's your lucky day. That's our final answer on that question. Just make sure that when you're factoring by grouping that your parentheses match. If they don't match, that means you have a little more work to do as far as thinking about what your common factor is. Or maybe you just made a small mistake. It happens. Alright, and here's this new stuff about inverses. This has not been tested yet, but let's hope for some good scores. We don't have to test it ever again. When you're finding an inverse of a function, that's a two-step process. You're going to switch the x and y, and then you're going to solve for y. So remember, f of x is just a really fancy way of saying y. So step 1 is us switching the x and y. So we're going to write down x equals 4y minus 9. And then step 2 would be you solving for y, which might take you a couple steps. So I'm going to, let's see what I'm going to do. I'm going to add the 9 over. So like x plus 9 equals 4y. And then divide everything by a 4. So 1/4 x plus 9/4 equals y. And then we tried to make a big deal about notating who's the inverse and who's the original. So if you forgot it, you're kind of in luck because I went ahead and named it f inverse for you. So you're just going to write your function down here, which is 1/4 x plus 9/4. If you wrote that in an equivalent form, not necessarily broken into fractions like this, that is okay. Just watch your simplification. Alright, and then some properties of inverses. You're going to have one of those like, which of the following are true things show up on the test, so make sure you know all these. Domain and range switch. That's the big idea there. Because x's and y's switch, that means domain and range switch. You can also say the word reverse if you don't like the word switch. Whatever. Alright, is this a sometimes, always, or never fact? Let's see, a function and its inverse are the same. There are functions that are their own inverse, but that doesn't always happen, so this would be a sometimes moment. Can you have a function whose inverse is not a function? And yeah, you absolutely can have that. And that has to do with the horizontal and vertical line test. So let's talk about this last part. If the original passes the what, then the inverse is a function. So if you need to know that the inverse is a function, that means the original has to pass the horizontal line test. And then if the original and the inverse are reflections across the line, so that was a very special line that went through the origin, remember the line y equals x. So you need to study all of those facts and properties about inverses. I would say that's a pretty tough section of the test, is figuring out which ones are true and which ones are false and which ones apply to the thing that's drawn. So I don't want to give you too much about what the test looks like, but you definitely need to know those facts right there and have them, you know, backwards and forwards. I might want to note on your review here, since the domain and range switch, and the reason for that is because x and y switch. Okay, so these are all the same kind of facts. X and y switch, so the domain and range switch. All right, good luck everybody.